Hello, good morning one and all. Today we will going to discuss about the next part in the random process, that is the Gaussian noise and the type of the noise. I hope that all you like to my previous videos, and today we will going to discuss about the Gaussian process and the noise. Gaussian process is the very important part in the random process, and based upon that what are the different types of the noise we will going to discuss here. Then what is the meaning of the Gaussian noise? See here, basically in case of the Gaussian noise, the random variable, in the random variable there are n number of the experiments, and based upon the n number of the experiment, individual experiment have given its own output, and combination of the all the experiments we have come to the conclusion and to find out the final outcome. So that the random variable y is defined with the help of this equation. Based upon this equation, what are the different parameters we'll be going to discuss here. The y which is equal to summation of I which is equal to 1 to n ai into xi. A of I are the constant. This is the constant parameter, and sometimes this constant parameter will be taken outside the integration sign or any mathematical operations. So x of I are the random variable, and that x of I are the random variable, and y is the linear function of the x of I, means it is the linear function of the x of y. Then we refer to the y as the linear function of the x of t, means this y as the linear function of the x of t, means x of t is the random experiment with respect to the time duration t. Then if the weighting function g of t is such that the mean square value of the random variable y is the infinite, and if the random variable y of the Gaussian distribution random variable of every g of t in this class of the function is the process of x of t, is said to be Gaussian process, which is called as the Gaussian process. Means the Gaussian process x of t is depends upon the two parameter. First parameter about that, the g of t. Then what is the g of t? G of t is such that the mean square value of the random variable y. It is the mean square value of the random variable y. And if the random variable y is the Gaussian distribution random variable for every g of t in this class, is the function that process x of t is said to be Gaussian process. Then in another word, the process x of t, means it is the process of x of t is the Gaussian process if every linear function x of t is said to be Gaussian random variable, means that random n number of the experiment, for example n1, n2, n3, in this way up to the here we have n of t times we have to be keep the n number of the experiments, means here the Gaussian process is every function of the x of t is the Gaussian random variable, and the Gaussian process has many properties that makes the analytical result possible. The random processes produced by the physical phenomena are often such that the Gaussian model is the appropriate. Then in case of the random variable y, means here random variable y has the Gaussian distribution function if the probability density function, means which is called as the probability density function, is generally indicated by the PDF. Here is the PDF, and PDF is a stands by here the PDF is a stands by the probability density function, and from that probability density function the fy of y, means here f of y which is equal to 1 upon square root of 2 pi sigma y exponential function, means it is also written as e raised to here minus here y minus mu y, here is the y minus mu of y bracket raised to square upon 2 sigma y square. Here is the 2 sigma y square. Means this is the whole property. It will become to the exponential function e of y. Means here is the e raised to this parameter. Means mu of y, means mu is stands for the mean of the random variable y, and sigma square y is the variance of the random variable y. Means y is the n number of the experiment you want to do this here. Then if the Gaussian random variable y is the normalized to have the mean of the 0 and variance of the 1, such normalized Gaussian distribution, and that normalized Gaussian distribution or probability density function and cumulative distribution function, these are the two distribution function, and both are inversely together. Means here PDF is the derivative of the CDF and CDF is the integration of the PDF. That part we have seen here. Then if the Gaussian random variable y is the normalized to have the mean 0, mean of a 0 and mean of the 0, and the variance of the 1, such normalized Gaussian distribution is written as n of 0, 1. Means the maximum value is the 1 here. Means suppose with reference to this diagram, your y-axis parameter should be varying from 0, 1, 2, 3, 4 up to the n number here, and here minus 1, minus 2, minus 3 up to the minus n number. Means your value should be varying from plus n to minus n, and here the x-axis parameter that will be varying from 0.2, 0.4, 0.6, 0.8 and 1. Means fy of y, means this parameter f of y of y, this parameter f of y of y, this is the parameter, and this parameter will be going to change here 0, 0.2, 0.4, 0.6, 0.8 up to the fy of y. Means here fy of y is basically is written as the normalized Gaussian distribution function 1 upon root 2 pi exponential function of minus y square upon 2, y square upon 2. Then what we do, based upon there are n number of the properties for the Gaussian process. The first property is that the Gaussian process, the x of t is applied to the stable linear filter, then the output of y of t is also called as a Gaussian. Means if the Gaussian process x of t is applied to the stable linear filter, then the output of y of t is also called as the Gaussian. Means x of t is the one of the event, y of t is the another event, x of t is the input of the stable linear filter, and y of t is the output of the linear filter, which is in the form of the Gaussian. Then second property, in case of the property number second, consider the set of the random variable, and that set of the random variable x of t1, and that x of t1 should be varying from x of t1, x of t2, x of t3 up to the x of t of n, and which is obtained by observing the random process of this random experiment, which is represented by x of t at a time t1, t2, t3 up to the t of n. Means this is the random process, and in that random process the n number of the random experiments with respect to the time duration t1, t2, t3 up to the t of n is x of t1, x of t2, x of t3 up to the x of tn. Then if the process of x of t is the Gaussian, then the set of the random variable are jointly Gaussian. Means if that all the events are joint probability, and if that the joint probability, it will be given as the jointly Gaussian for any parameter of the n with their n-fold joint probability density function. Joint probability density function means PDF, being completely determined by the set, its mean and variance. Means is represented by mu of x at a time duration t of I, which is equal to the expected value of the random experiment x of ti, and the value of this I should be varying from 1, 2, 3 up to the n number of the experiments. Then the set of the autocovariance function. The autocovariance function is depends upon two parameters, that is t of k and t of I. I is also varying from 1, 2, 3 up to the n number of the parameter, and k should be varying from 1, 2, 3 up to the n number of the parameter. Means both the t parameters should be varying from 1 to n and 1 to n. Then the Cx of tk ti, which is equal to the expected value of x of tk minus mu of x of tk into x of ti minus mu of x of t of I. So k and I, its value should be varying from 1, 2, 3, 4 up to the n number. Then consider the composite set of the random variable, and that composite set of the random variable x of t1, x of t2, x of t of n, and its outcome should be varying from y of u1, y of u2, y of u3 up to the y of u of n. Then we say that the process of x of t and y of t are jointly Gaussian, then if the composite set of the random variable also n and m parameter both are the jointly parameter. Means in case of the joint probability, here the Gaussian probability, and the joint Gaussian if its parameter for x and y are joint or jointly. Then third is that the property number 3, if the Gaussian process is the wide sense stationary, and if it is the WSS or wide sense stationary, means for this case here the WSS, that is the wide sense stationary, then the process is called as stationary in the strict sense. Okay, means this is the property number 3. Then in case of the property number 4, if the random variable x of t1, x of t2 up to the x of t of n, then it is the uncorrelated. When it is the uncorrelated, if the value of I, this value is also varying from here 1, 2, 3 up to the n number of the parameters, and the value of the k should be varying from 0, 1, 2, 3 up to the n number of the parameters. If for this case the I which is equal to 1, 2, 3, 4 up to the n number of the parameter, and k which is equal to 0, here is not a delta, here is the 0, 1, 2, 3 up to the n number of the parameter, then for this case I is not equal to k. Here is I is not equal to k, and if the value of I is not equal to k, for this case the random variables are statistically independent, which is called as the statistically independent. Then the implication of this property is that the joint probability density function, the set of the random variable x of t1, x of t2, x of t3 up to the x of tn, can be expressed as the product of probability density function of the individual random variable in the set. I hope that up to the here, my dear student, all of you understand what is the Gaussian process, what are the different properties of the Gaussian process, how it will be intercorrelated. In my next video, we move towards the noise. What are the different types of the noise? What is its behavior? How it will be look like, and its mathematical derivation. If you like this video, please share this video, like this video, and write on the comment page. If any query, please write the comment on my comment page. Thank you. Have a nice day.